Okay, these functions that we're combining, basically what we're going to do is the operations that is expressed here, combine like terms, that kind of stuff. So this is not going to be too hard here. Um, the number one thing we want to do, though, is first determine the domains of these things. And because these functions are polynomial, the domain is all real numbers here, and it's also all real numbers there. Um, and now there, for any combination of these functions is going to be the intersection of these domains. Okay, so we're going to look at the intersection of the real numbers and the real numbers, which is just the real numbers. So that's the idea behind these. Again, adding these 6x squared, 7x squared, 7x, and minus 1. Okay, and now the domain is the intersection of this domain and that domain, which is the intersection of all real numbers, and all real numbers is all real numbers. Subtracting, same idea. Just make sure that when you subtract them, f minus g, so it's going to be x squared plus 7x minus 6x squared plus 1, because it's minus this in quantity, this entire quantity. Intersection of the domains, again, all real numbers. F times g, okay, so there we're getting x squared plus 7x and 6x squared minus 1. You're foiling that out and getting this stuff. Domain, all real numbers. This one's where you got to be careful. Okay, division shouldn't be too bad, but now what we're looking at is that it's still intersection of all real numbers. However, because you see we go from negative infinity to positive infinity, however, we can't have division by 0. So we take 6x squared minus 1, the denominator, say it cannot be 0. 6x squared cannot be 1. X squared cannot be 1 over 6. X then cannot be plus or minus radical 1 over 6, which actually ends up being radical 6 over 6 when we rationalize it. So x cannot be those things, positive or negative. So we go from negative infinity up to negative radical 6 over 6. We union then negative radical 6 over 6 to radical 6 over 6. Then we're going to union radical 6 over 6 to positive infinity. Of these problems, I think that's the biggest issue people have, is that domain restriction, because we cannot divide by 0. Find the inverse of this function. You've seen a couple of these that are on your review that have 2 x's in them on the exam, and there's only going to be 1 x. But this is pretty much the approach that you use. Y equals 1 over x plus 5. Okay, we write, instead of f of x, we write y. It's just easier. Input or interchange the x's and y's, and now try to solve for y. So I'm going to multiply both sides by y plus 5. Okay, do not try to multiply this through because you can instantly isolate the y value by dividing by x. So you get y plus 5 equals 1 over x, and now isolate y by subtraction, so 1 over x minus 5, and there we go. This one, remember, we talked about in class. We want to factor. We got x cubed minus 64. It's a difference of cubes, so that's going to go a minus b, a squared plus ab plus b squared. So here, okay, a in this case is going to be x, b is going to be 4. A minus b will be x minus 4, and then we'll go x squared plus 4x plus 16. This is one of your factors, so that is one of your 0. You're starting to see right here that that's the 0 that came from it, and then this is the factor that goes with it. Okay, so kind of answer these two things at the same time. Now we want to find the other factors that are showing up here. The way we do that is we factor this thing. Now it's not factorable because there are no two numbers that multiply together to give me 16 and add up to 4, so we're going to use quadratic formula. So negative 4 plus or minus b squared minus 4ac all over 2a. Okay, so 16, negative 4 plus or minus, we got 16 minus, so there's 32, 64, all over 2. 16 minus 64, 48. So negative 4 plus or minus radical negative 48 over 2. I bring the I out, negative 4 plus or minus I. Now 48 is also 16 times 3, so I'm going to make that 4I radical 3. That will simplify the negative 48. And then over 2. So now 2's cancel out in all of those, and it leaves me negative 2 plus or minus 2I radical 3. And if we go up here, hopefully that's what we see. Negative 2 minus 2I radical 3, negative 2 plus 2I radical 3. Those are those two results right there. Now down here, all they did is they take x minus that factor, and it gives you that one. Okay, x minus, let me see here. I'm going to write this way. X minus negative 2 minus 2I radical 3. So it's x plus 2 plus 2I radical 3. So that one is actually that one. And then we've got x minus negative 2 plus 2I radical 3. So it gives me x plus 2 minus 2I radical. What did I do? So we got that. That's that factor there. No, it's just rearranged terms. My fault. And that one is that one there. But once you have, like I said today in class, once you have these factors, if you just want to write this right here, I'm okay with that. You don't have to distribute if you don't want to. I'm okay with that right there. Don't have to distribute if you don't want to. Know how to do this problem.